guys, I hope you're having a great day today. I have a little something interesting going on with a couple plants here, and I just wanted to show you guys. This doesn't happen really often for me with house plants. Typically, sometimes outdoors it happens a bit more, but typically indoors, especially with my collection being predominantly succulents. The type of soil I use and medium typically keeps this from happening too much. But I have two varieties here, and I want to show you what they're doing and what's going on. So this first one here is a watermelon peperomia, and I had been looking for one for a while and found this one in a supermarket, and it looked fairly healthy, but it was hard to tell if the new growth was having some issues or if it was just small still. Well, now that I've had it for probably a couple months now, it's very clear as this new tissue is growing out that there is definitely a problem. So on these healthy leaves, you can see like this one here, this is a nice healthy leaf. There's some natural curving that's just fine. There's sometimes a little bit of cupping. You can see this is, you know, a little bit spoon shaped, and that's fairly normal. But it should be fairly minimal. When it starts doing making leaves like this, where they're really cupped up here, you can see, and the edges are rough. This is a good example here. See how this is just, this hasn't been, this looks like maybe it got wind blown or chewed up by something. Nope, they grow out this way. This is, it opens up and it splits. There's one right here that is split down the middle. Now nothing happened. This wasn't overwatered. This grew out this way. This didn't split. It looks like it was, you know, really cupped and tight and then got overwatered or something and split open, but that's not actually what's going on. You can see this one here has its edge very turned up. Now, what this typically is a deficiency, and usually calcium or magnesium. There are a few other deficiencies that can cause similar type tissue damage, but generally it's calcium, and in this case, I'm gonna bet on it being calcium. I am gonna give these guys calcium and magnesium both, just because that's not gonna hurt them, and just in case. But with this guy, it was planted in what looks now to be, which I really didn't look at it, I just kind of poked it on a shelf and was waiting to see what happened, and I haven't repotted it yet. And it's planted, it looks like it's pure peat or very close to pure peat. And pure peat doesn't have a lot of calcium in it typically. And so a lot of the soils that we use for succulents, you know, like pumice and a lot of the different stones and granite, people even use gypsum sometimes in potting soil mix, limestone, shale, all of these things have quite a lot of calcium and various other minerals in them, and plenty usually to keep them happy in a pot for quite a long time. But peat, if they're not being fertilized correctly, and with plants that come from high production nurseries, they are forcing them to grow really, really rapidly. They're feeding them a lot of food in a very absorbable form so that they grow really quick so that they can ship them out. And after that initial kind of growth burst dies, just think of it kind of like if you drank an energy drink, and yeah, you get a surge and you look really great, but when you come down off the other side of 4 cups of coffee and 3 Red Bulls, sometimes you don't look so good. And we don't see physically in our own bodies how this depletes our mineral stores in particular, like energy drinks, but it's very similar with plants and being stimulated to grow too fast, too much. So it's not highly unusual for plants to do this after you bring them home, especially if they're not repotted. I almost always quickly repot mine into a mixture with a lot more mineral rich soil, but with peperomias, they're not a desert succulent, so they don't have the same type of needs, and it wasn't a big rush because I knew I wasn't going to overwater him, and so I wasn't in a super hurry to pot him up. However, it appears that he has got some deficiency going on here. Okay, let me show you the other one real quick. This guy, this is a crassula type. Crassula strayi. And it was hard for me to tell for quite a while. These guys were just cuttings, and they were rooting really, really slowly, and the top tissue was starting to look a bit different, and I wasn't sure if that was just because they were taking too long to root or if it was a deficiency. Well, now things have gone on farther, and I'm about 99% sure it's a deficiency. And these were actually the exact same. These guys are a more shade growing, water-loving type of succulent. They usually grow along riverbeds, and so I wasn't super concerned with getting it out of the peat that it had been potted in, that the cuttings were put in when I bought them. They were put in what looked to be straight peat. It might have had something else, but it was very much peat heavy. It didn't have pumice or other things like that in it really. And but I wasn't in a huge hurry because they're not super prone to rot, and I just didn't need to hurry. And so I repotted these guys a couple weeks ago into a mixture that's rich on minerals, and so hopefully they will adapt to that. But I'm also going to treat them right away because there's an obvious deficiency going on. And what that looks like on this variety, which it will look different from variety to variety, but it looks like deformed leaves. The leaves start curling, mostly the new growth that grows out. This is like super compact and dense. It should be, you know, more like this and then grow out just 2 leaves at a time. And this really highly compact stuff. It's hard to tell here, but there's a lot of deformity, a lot of, you know, one side is larger than the other leaf, one is curled, and they're all starting to curl. Calcium is needed to pretty much make every single tissue in a plant. And so when calcium is deficient, the tissue gets really deformed and can just grow out in all kinds of gnarly, just really weird ways, because it doesn't have the nutrients that it needs to make the structure of the plant. So the new growth doesn't have the correct tissue structure, which often to us just looks like curling or deformity. Calcium also is a transporter nutrient, so it grabs on, it has a positive charge, and so negatively charged other nutrients latch onto it, and the calcium actually carries it into the plant. So calcium isn't just needed for calcium's sake. Calcium is needed to absorb a lot of other nutrients as well, or for the plant to be able to uptake them so that it can absorb them. So this could be some other type of nutrient deficiency that's being also caused or compounded by the calcium deficiency. We'll see if me upping the calcium for both of these guys doesn't make a fairly fast recovery, then I may work on some other nutrients. But typically, I mean, a lot of times if your soil can even have a lot of the nutrients it needs, but if it's calcium deficient, your plant can't uptake those other nutrients. So you don't a lot of times actually need to add a bunch of other nutrients in. You just need to get calcium and sometimes magnesium as well into the plant so that it can uptake all of the other nutrients like it's supposed to. And so this guy, like I said, I already repotted him a couple weeks ago into a much more mineral heavy soil, so he's good on that side of things. He doesn't need to be repotted again because I did go ahead and do that. This guy is still, this isn't the pot that it came in, but it slipped down inside of here, so he is still in the pot that he came in, and he still has this peaty soil, so he is actually going to get some new soil with just a few additives in it. These guys don't need a really rocky desert soil. The Peperomia are much more tropical growers, predominantly from South America. And so they really don't need that. But since this guy's having a deficiency, I'm going to add in a bit more pumice and a few additives on the calcium side to improve the growth long term. Now, short term, what I'm going to do and why I was making this video today is short term, I'm going to use eggshells to give these guys a quick boost of calcium. I'm also going to use Epsom salts to give them a really quick dose of magnesium, but the eggshells is what I wanted to talk about in particular today, and just kind of show you what I do and why I do it and how I do it. In case anyone's interested, a lot of people know about using eggshells in gardening. A lot of people talk about it like with tomatoes for blossom end rot, which is a calcium or magnesium deficiency typically calcium. And a lot of people talk about that, but what a lot of people don't realize is that using eggshells just in their raw state, even if you break them up or grind them up, they still take quite a long time to get into a form that is actually absorbable by the plants. So we'll have a little bit of a mineral lesson here. I really will try to not get too geeky, but I do want to explain it because it matters, and it's once you know what's happening, it makes a lot more sense. Some of the recommendations you might hear for plants that are deficient on calcium. So with eggshells, eggshells are 95% calcium carbonate. They're like 1% like calcium phosphate or magnesium phosphate, and 1% a different another type of magnesium, and then like 4% just organic material, which is usually the inner lining of the eggshell, you know, that's inside of the shell, not the actual shell itself. It's the membrane on the inside that is usually counted as that organic material. But for the most part, by far, they are composed of calcium carbonate. Now, calcium, or any mineral really, but I'm just going to talk about calcium right now. Calcium is a mineral that has both organic and non-organic states. And now usually when we think of organic, we think of natural or better or, you know, more absorbable or something. But with minerals, all organic or inorganic means is because calcium is a positively charged ion, it attracts negatively charged ions to it and other nutrients. And those attach to calcium super easy. And an example of that would be carbonate. Carbonate is a carbon atom, carbon-based, meaning organic atom, and it attaches very easily to calcium. And thus we have calcium carbonate, right? Or citrate, for example. We have calcium citrate. Citrate is attached to the calcium. It isn't part of the calcium. It is a different molecule that has attached to the calcium ion. So when humans or animals or plants absorb calcium, we typically absorb it with another additive. So like we take calcium carbonate. We very rarely take calcium in its inorganic form, which is just pure calcium, Ca2. So we rarely take it like that because our bodies cannot absorb the inorganic form. It either needs to be ionized, which means ground up and made super tiny. That's a very simplified version of what ionized means, but it's very tiny particles which can be recognized by our body, or it needs another chemical component to attach to it, which then makes it organic. So if a carbon molecule attaches to a calcium mineral, then we call it organic now. It is now in its organic phase. And so if any carbon-based atom, which is, you know, there's many that can attach to calcium, attaches to a calcium molecule, that is when we call it organic. And so with plants, they actually need calcium in an inorganic form, which is how it's usually found in nature because it's being leached out of rocks or, you know, various other elements in the ground. Typically stone. And so if plants weren't able to absorb inorganic or natural, I'm just going to call it for the purpose of this video, calcium, pure calcium from the, which it's not really pure, but that's a whole nother thing. Calcium from the soil, if they weren't able to do that, we'd be really up a creek without a paddle. So it's great that they are. However, the process of converting the inorganic calcium from the ground to an organic state in the plant, and then to get it back into the ground as an inorganic state again so that the plant can then reabsorb it, is quite a process. And for eggshells, for example, if you were to crumble them up and put them in the soil, it would take about a year for this plant to be able to actually get any benefit. Here comes the kitty. Hiya, kitty. Any benefit from those shells. So someone might add shells to their tomato plant that's having blossom end rot problems, or to a house plant, and they wait and it doesn't improve at all. So they conclude it didn't work and it wasn't a calcium deficiency. Well, that's not actually true. And to add to that, a year to break down eggshells, that is only if the proper microorganisms are present in the soil, which, depending on the type of soil you have and how much it's been treated with various and sundry pesticides, etc., a pot in a house plant, the bacteria count can be kind of minimal, and so it can take even longer for the eggshells to break down back into the inorganic state that the plants need it to be, to absorb it. So what can we do to speed that up? And how do we do that? One of the ways you can do it is by increasing the surface area. So obviously taking a whole eggshell and just putting it in the plant, it's going to take a lot longer to break down versus if you crumble it up. And crumbled up, you know, might take 6 months. Whole might take a year. Crumbled can even take up to a year, but in a compost bin or something like that, this is an area. Yeah, the year is kind of a generous or conservative, I guess I should say, estimate, because that's assuming it's in a compost bin with a lot of bacteria and stuff. But taking it from a crumbled eggshell and putting it like in a coffee grinder and grinding it up into a powder, that gives you way, way, way more surface area. And so in nature, how these minerals go from organic back to inorganic in nature is typically through interaction with bacteria and microbes in the soil. And these microbes release urea in various forms, and that acid ends up basically ungluing whatever, like in this case with an eggshell, the calcium carbonate. So you have your calcium molecule and then the carbonate is stuck to it. And the acid that these bacteria release actually separate the carbon, and that evaporates off, and what you're left with is your calcium molecule that the plant can then absorb. And so these bacteria just slowly break down things like eggshell, like limestone, like various other naturally occurring calcium sources in nature. And they break them down beautifully. But sometimes we don't want to wait for them, right? So the first way to speed it up is just by making the particle size smaller. So grind up your eggshells, and it will speed up the process a lot. But even if I were just to mix in grind up eggshells with my water or my soil here, it could still take several months for that to get into a form where the plant can use it. So to speed that up, one of the easy ways to do it at home with eggshells in particular, which there are lots of ways to get your plants calcium, guys. So don't misunderstand me there. There are plenty of ways to do this. I am just showing you how I do it. And I like using eggshells. I like using natural things for my plants, but I do want to speed up the absorption a bit. And so this is just the process that I go through. And one of the ways that you can speed it up is to use vinegar, which acts as an acid, obviously, and it reacts with the calcium carbonate in the eggshells, and it actually does, basically it does the process that the bacteria would do for you over time in a much faster, accelerated manner. So I am going to move my camera and show you guys my eggshells, and we're going to do a little bit of an experiment. I think I'm going to make this a two-part video probably. So if this ends up being 2 parts, I will probably just cut off here and we'll start part 2, which is the actual making of the solution. And I will continue to talk about what we're doing and why we're doing it. So if that's the end, I think this will be the end of this video. We'll just go ahead and make it a call. So that's the end of this video. You can find part 2. There will be a link in the description box below. I will be sure and put the link to part 2, which will show you how to make the eggshell solution and what to do with that. And I will see you in part 2. Until then, happy growing!